This video illustrates how to use Java.util.HashMap in Java for solving problems and storing data that can be stored in a Python dictionary. So I'm going to begin with the first example. In total, I'm going to show you two examples first. The first example, which basically asks you to write a Java method that counts the number of unique permutations of a given string. For example, if the given string is dad, D-A-D, then the number of permutations should be calculated as 3 because there are 3 different permutations of that. One is D-A-D, one is ADD, and the last one is DDA. So in order to solve this, I'm going to use hash maps from the Java.util package. Basically, I'm going to use this formula for counting the number of linear permutations of n unique items. We can use simply the formula of n factorial, which means you just need to multiply numbers from 1 to n, or I should say 2 to n, to get to the number of linear permutation for n unique elements. But in this question, I really can't use this formula directly because if you have a word with repeating characters or repeating letters, like in this case, when D is repeated twice, then this formula doesn't really work. This formula for the example of DAD gives me 3 factorial, which is 6, which is twice as many as the real number of permutations. The reason is because D is not unique in this. You have like 2 separate D's. You basically count every permutation twice. So, for example, that is counted twice if you use the formula in factorial. One is the first D, the second D, or the second one would be the second D, then A, then the first D. Long story short, this formula doesn't work when you have repeating characters in a string. So in order to solve the problem in general case for strings with repeated characters, we're going to use the second formula, which is a little bit more complex. It says if you have n elements that are not unique and they are made of multiple repetitions of different elements, let's say m1 repetitions of element a1, m2 repetitions of a1 repetitions of element m1, A2 repetitions of element M2, and AK repetitions of element MK, then the number of linear permutations would be n factorial over A1 factorial, A2 factorial, A3 factorial, all the way to AK factorial, right? So as an example, for the string that I mentioned, you have basically A1 equal to 2. That's the number of elements, element D, which is the letter D, and A2 would be 1, which is the number of A's, right? So the formula that we have is n factorial over the product of AI factorials. So basically, using the formula, we basically get 3 factorial over 2 factorial, that's A1 factorial, times 1 factorial, which is a 2 factorial. And that's basically equal to 6 over 2, which is equal to 3. So I'm going to use this formula for the generic case. In order to do that, I have to count how many times each character is repeated in a given string. So to do that, I use Java.util.HashMap. That's a perfect application of hash maps. So let me show you, how it works. We're gonna begin with the main method, which basically calls another method count permutations, which gets a string and returns an integer. And now we're gonna look at this count permutations. It's a static method, gets a string, returns the number of permutations, which is an integer, right? The first thing we need to do in this method is to create a hash map, because we're going to count the number of occurrences of every letter. So this is to count number of occurrences of every letter in the given string. Then for every character in the string str, we're going to do this map.put c comma map.getOrDefault c as 0 plus 1. What does that mean? Let me make this a little bit easier to understand. So instead of doing this all at once, I'm going to break it down into small pieces. First, I'm going to say, let's come up with the current frequency or current number of times that a letter has occurred or has appeared in this string, which is going to be map.get c, right? And then I'm just going to say, all right, so whatever the current frequency is, I'm going to plus it, because this is the next time I'm going to visit this character. And then at the end, I'm going to basically say map.put. Now the same character frequency would be the current frequency, but because I have incremented the current frequency, now I have to update the map. Right? Basically, this will do the job with one issue. The issue here is if the character is visited for the very first time, this method map.get throws an exception, because if the get receives a character that doesn't exist in the map, it's going to throw an exception saying this character doesn't exist in the key set of this map. So in order to fix this, we need to first check to see if this character exists in the hash map key set. This hash map, by the way, is a hash map between characters and integers. So that means the key is a character, the value is an integer, and that's basically what I want to find out how many occurrences of every letter I have. So it should be a mapping between characters and integers. So in order to make sure get doesn't throw an exception in this line 25, I gotta do this. I gotta say if map dot contains key c, if that's false, then I'm going to say map dot put c and 1, right? Because that happens in the very first time. Otherwise, I will do the 3 lines that I mentioned, which means get the current frequency, add current frequency by 1, and then update the frequency. So this is the case where C appeared for the very first time. This is for the case where C has appeared multiple times. So this is after the very first time. So this is the code, but this is too long, so we're gonna make it shorter. In order to make this shorter, I'm gonna use getOrDefault. Right? I told you get can throw an exception if the character is not in the key set. In order to avoid that, we're gonna use getOrDefault. GetOrDefault doesn't throw an exception, right? If the character doesn't exist in the key set of the map, getOrDefault basically returns the default value, whatever default value you pass as its second parameter. So it gets a character, and it gets the value, the default value, basically. If the character cannot be found in the key set, it's gonna return the default value. The default value, the default frequency of every character is 0, right? If your character hasn't appeared once, its frequency should be 0. And then I will get that using get default, and then I add it by 1. That becomes the updated frequency, the new frequency, and then I will use map.put to update the frequency of the character C to its new frequency. So instead of using these, let's say 6 lines, I can use this line, and that's it. That's pretty much does the job of the other lines. So I'm gonna use the simpler code here. Let's comment the rest out. I don't need them because that's easier to deal with. And that's pretty much it. So this for loop is going to go over the whole string from the very first character, the leftmost character, all the way to the very last character, the rightmost character, and it's going to count how many times each character has appeared in the string, right? And after this for loop is over, then it's time to apply the formula. The formula was this, right? So let's do that. I'm going to say, let's first, this formula had a numerator and factorial, and it had the denominators a1 factorial, a2 factorial, all the way to ak factorial. So what I'm going to do is I'm going to begin with an integer return value set it equal to the factorial of the length of the string, where factorial is a method that I just defined, set RB to 1 for every, RB stands for return values. So for every I from 2 to n, I multiply RB by I. That basically means multiply all numbers from 2 to n. I skip 1 because, multiplying 1 by any number gives you the same number. So it's a neutral operation. So let's not do that. And then at the end, I return the RB. Okay, so if this is the factorial method, I will use it once here for the numerator. And then I use it multiple times in this for loop for the denominator. The denominator has a product of multiple factorials. The factorials are going to be the values stored in the map, right? So this is what I will say. For every character C map.keyset, if map.getC is not 1, then divide RV by map.getC. So after I find the numerator, then I keep dividing it by every element in the denominator. So gradually divided by all the elements in the denominator. Actually, this should be factorial of map.getC. So I should say factorial of map.getC, because you just keep dividing it by the number of occurrences of every single character, factorial, right? So you just divide it by factorial of every single number, and then at the end you return RV. Don't worry about whether or not the RV is divisible by the factorial of the number of occurrences of every character. That's 100% true. Always, n factorial is always divisible by, let's say, a1 factorial and a2 factorial and a3 factorial. That's a fact that you can prove it in number theory. We don't want to get into the details of it. And at the end, you can return that. So if I pass, let's say, that here, it's going to return 3. If I print the number of permutations for that, it's going to print 3. And then I'm going to do one more, a little bit more difficult. Let's say banana. Banana has the following counts. Letter B has appeared once. Letter A has appeared 3 times, and letter N has appeared twice, and the total length is 6. So it's going to be the number of permutations should be 6 factorial over 2 factorial, 3 factorial, right? Which is going to be equal to 720 over 12, which is going to be equal to, I guess, 60, right? And let's see if that's the case. If I run it, you should get 60. Yeah, that's right. So that's pretty much the first example. Let's get into the second example. The second example is another interesting example of application of Java.util.HashMap. This one is a different example. It says, let's say there's a group of friends who owe each other money for different reasons. Let's say Alice needs to pay $20 to Bob for an Uber ride. Bob needs to pay, let's say, $45 to Anne for dinner, and Alice needs to pay $30 to Anne for groceries, right? Let's use Java.util.HashMap of a string to integers to find out how much each person owes or is owed, right? So in this case, the person who owes the most is going to be Alice, because Alice has to pay $20 to Bob and $30 to Anne, a total of $50, right? So we're going to find out this total of $50 for Alice. For Bob, Bob needs to receive, let's say, $20 from Alice and needs to pay $45 to Anne. So if you subtract 20 from 45, the answer would be 25. So Bob only needs to pay, Bob owes only $25 in total to other people. And the person who needs to receive the most money is going to be Anne, because Anne is going to receive $20 from Alice. $45 from Bob, and then $30 from Alice. So Anne in total will need to receive a total of $75, right? Let's see how this is possible. How do we basically find the total amount of money that each person owes or is owed, right? I should have said how much in total each person owes or is owed. So that's basically the total, right? Let's see how we can automate this using Java.util.HashMap, right? My assumption is the information that I just mentioned, that Alice owes $20 to Bob, Bob owes $45 to Anne, and Alice needs $30 to Anne. They're all stored in an input file called input.csv, which is stored right here inside the project's directory input. It's in input.csv. Basically, it's a CSV file, comma separated value file. It's a format for tabular data. It's a table of 3 rows and 3 columns. The first column writes the name of the person who owes money. The second column writes the name of the person who needs to receive the money. And the third column basically specifies how much is the debt, right? And basically you have Alice, Bob 20, Bob and 45, and Alice and 30, right? This table can be much longer. It can have like many more rows, but it's always have 3 columns. The first 2 columns are strings, specifying the names of people, and the third column is the dollar amount, assuming that the dollar amount is always an integer, so it's going to be an integer column. So let's get into the code. I'm going to show you how it's possible to solve this problem as soon as possible using a hash map. We're going to begin by specifying the directory inputs, I should say, path in the file system. So it's a final string input, and it's going to be system.getProperty user.dir. This is going to return the directory, the path of directory, the absolute path of directory that contains this project. And then in this project, I should go to the input directory. So /input/. That's the final string that I'm going to use whenever I want to access the files inside the input directory. And then I have the main method, which throws an exception. I should have handled the exception by catching it, but I was a little bit lazy. Then I said, let's create a scanner with new file inputs plus input.csv. I assume the input information is stored in input.csv. Then I have created a hash map of a string to integers. And I call this accounts because it shows the balance of every single person. And I'm going to update this hash map after scanning every single line of the input.csv, because every line contains information regarding two people, the lender and the borrower. Let's begin by going over the whole file while stub has next line. I'm going to get the line and split it over comma. So this way I will have three tokens. The first token is the name of the borrower. The second token is the name of the lender. And the third token is going to be parsed using integer.parseInt that shows the amount that has to be exchanged between the two people. And then I will do accounts that put borrower, accounts that getter default, borrower and 0 minus amount. To make this list possible, or to make this aggregation possible, to make the to basically accumulate all the debts, I assume that the borrower has negative balance while the lender has positive balance. So basically, what I'm looking for here is some map like this. I'm looking for a map that basically says Alice, who needs to pay a total of 20 to Bob and 30 to Anne, which becomes 50, is mapped to negative 50 because Alice owes money, so the balance is negative. While Bob, let's say, let's first put Alice and then Bob. Then I'm sorry, not Alice, Anne. Then Anne, who need to receive 30 from Alice and 45 from Bob, will have a positive balance of 75. And Bob here has a negative balance of negative 25. Why negative 25? Because he needs to receive, let's say, $20 from Alice, but he has to pay $45 to Anne. So the net would be negative 45 minus 2, or 20 minus 45, which is negative 25. So we're going to create this mapping between people and integers. So this is how I do it. I use getter default because of the same reason I mentioned in example 1. If I say get, it may throw an exception, but getter default is the most convenient way to get the value of a given key from a map, because if the key doesn't exist in the key set, it's going to return the default value. So the default value for any person is going to be 0. Every person by default has 0 balance, right? But after you get the current balance using accounts that getter default borrower or lender in the next line, we're going to adjust that by subtracting the amount from the borrower or adding the amount to the lender's balance. And then this becomes the new value. We're going to pass this as the second parameter to the accounts that put, so that the borrower and lender's account balances get updated. Now, borrower will have a balance equal to the previous balance minus amount, and lender is going to have a balance equal to the previous balance plus an amount, right? And when you do this for all the lines of the inputs, for every single line, when you finish parsing the whole file, when you get out of the while loop, then the numbers are going to be the correct numbers to show the total money that each person owes or is owed. Let's run it and see it for ourselves. This one says the summary of account. Anne needs to receive $75 from others. Bob needs to send a total of $25 to others. And Alice needs to send a total of $50 to others. Let's see how this last part works, because I did fill out the map with the proper information, but I didn't show you how this can be interpreted. I print out summary of accounts colon space new line, and then I have this for loop. The for loop goes over every person in the accounts key set and checks the balance. If the balance is positive, that means the person needs to receive money. So we print out person needs to receive a total of $, whatever the person's balance is from others. If the balance is negative, then we're going to print out person needs to send a total of. The amount would be the negation of the amount that is stored in the map, because if I say the actual amount without the negative sign prints a negative number, which doesn't make sense with the sentencing that I have here, because it's I said we have to send this much money. The money should be positive, right? The negative money doesn't really make sense in this sentence. So I have to negate that and say the person needs to send a lot of negative accounts that get person to others. If the balance is 0, we don't need to do anything. So that's why I have like two ifs. One is for positive, one is for negative, because there's a third situation when the balance is 0, so we don't need to do anything in that case. That's pretty much it. Thank you for watching.